Good morning, everyone. Myself, Kishan Shinde, currently pursuing my engineering in Sri Venkateshwara College of Engineering in the domain of artificial intelligence, specialization in computer science. So today's topic is typical CNN, that is convolution neural network architecture. So introduction to CNN architecture. Convolution neural networks are the type of deep natural networks designed for processing structured grid data such as images. CNN are widely used in computer vision tasks such as image recognition, object detection, and image segmentation. The architecture of CNN typically consists of convolutional layers, pooling layers, and fully connected layers. Convolutional layers are the building blocks of CNN and are responsible for extracting features from input data. Each convolutional layers applies to a set of filters to the input data to detect patterns and features. The output of convolutional layers is called feature map, which represents the presence of different features in input data. So, in the given image, you could see the convolutional neural networks, that is layer 1, layer 2, and classifier. Convolutional layers, the input layer, hidden layer, and output layer. Input layer. It is a layer in which we give inputs to our model. The number of neurons in this layer is equal to the total number of features in our data. The number of pixels in the case of an image would be an input layer. So the hidden layer, the input from the hidden layer is then fed into the hidden layer. There can be many hidden layers depending on our model and data size. Each hidden layer can have different number of neurons which are generally greater than the number of features. The output from each layer is computed by matrix multiplication of the output of the previous layer with learnable weights of that layers and then by addition of learnables biases followed by activation function which makes the network nonlinear. The output layer. The output of the hidden layer is then fed into a logistic function like sigmoid or softmax which converts the output of each class into a probabilistic score of each class. In an architecture, the convolutional layer applies filters to the input image to extract features. The pooling layer down samples the image to reduce computational and fully connected layers makes the final prediction. The network learns the optimal filters through backpropagation and gradient descent. Pooling layer are used to downsample the maps generated by convolutional layers. Common pooling operation include max pooling and average pooling, which reduces the spatial dimension of the feature maps. Pooling helps to make the network more robust to variations in input data and reduces the computational complexity of the network. How convolutional layer works? Convolutional neural networks are neural networks that share their parameters. Imagine you have an image. It can be represented by a cuboid having the length, width, and height. So now imagine taking a small patch of this image and running a small neural network called filter or a kernel on it. Say with say k outputs and represents them vertically. Now slide that neural network across the whole image as a result. We will now get another image with different width, height, and depth. Instead of just RGB channels, now we have more channels but lesser width and height. This operation is called convolution. If patch size is the same as that of image size, then it will be a regular neural network. Because of this small patch, we have fewer weights. How convolutional layer works? CNN are trained on larger datasets using backpropagation and gradient descent. The model's performance is evaluated on a separate test set to measure accuracy and generalization. Techniques like data augmentation, data transfer learning can enhance the performance of CNN models. Layers to build convolutions. A complete convolutional neural network architecture is also known as convolutions. The convergence is sequence of layers and every layer transforms one volume to another through a differentiable function. Types of layers. Datasets. Let's take an example by running a convergence on an image of dimension 32 cross 32 into 3. Input layer. It is a layer in which we give input to our model. In CNN, generally the input will be an image or a sequence of image. This model holds the raw input of the image with the width 32, height 32 and depth 3. Convolutional layer. This is a layer which is used to extract features from the input dataset. It applies a set of learnable filters known as kernels to an input image. The filters or kernels are smaller matrices, usually 2 cross 2, 3 cross 3 or 5 cross 5 shapes. It slides over the input image data and computes the dot product between kernel weights and corresponding input image patch. The output of this layer is referred as feature maps. Suppose we have total of 12 filters of this layer, we can get the output volume of the dimension 32 cross 32 into 12. Layers to build components. Activation layer and pooling layer. By adding an activation function to the output of the preceding layer, the activation layers add non-linearity to the input network. It will apply an image wise activation function to the output and the convolutional layer. Some common activation functions are ReLU, that is max 0 and x, tan x and leaky ReLU, etc. The volume remains unchanged, hence output volume will have dimension 32 cross 32 cross 12. Pooling layer. This layer is periodically inserted in a convergence, and its main function is to reduce the size of a volume, which makes the computation fast, reduces and memory, and also prevents overfitting. Two common types of pooling layers are max pooling and average pooling. If we use max pooling with 2 cross 2 filter and stride 2, the resultant volume will be the dimension of the 16 into 16. Yeah, in the given image you could see the same. So this is the classification being done. So advantages: good at detecting patterns, features in an image, videos, and audio signals. Robust to translate and rotation and scaling invariance. End-to-end training. No need to manually feature extraction. Can handle large amount of data and achieve high accuracy. Disadvantages: computationally expensive to train and require a lot of memory. Can be prone to overfitting if not enough data or proper equalization is used. Requires large amount of labeled data. Interpretation is limited and it is hard to understand what the network has learned. Application of CNNS. CNNS has numerous applications beyond image recognition, including object detection, facial recognition, and medical image analysis. They have been used in autonomous vehicles, civil surveillance system, and natural language processing tasks. CNNs continue to drive advancement in artificial intelligence and are a key technology in deep learning landscape. Conclusion: CNN architecture have evolved over the years from simple model like LeNet-5 to deep neural network like ResNet. Understanding the components of CNN architecture such as convolution layers, pooling layers, and fully connected layers is essential for designing effective layer networks. By leveraging the power of CNNs, researchers and practitioners continue to push the boundaries of computer vision and artificial intelligence. Thank you. Hope this the topic have made you understand something about the topic. See you in the next one. Bye.